So for number 10, you have to find when the function is continuous. So you set them equal to each other. So 3 minus x squared equals ax squared minus 1. And then you plug in negative 1. So it's 3 minus negative 1 squared equals a negative 1 squared minus 1. And when you simplify it out, it becomes 2 equals a minus 1. You add 1. So 3 equals a. For number 11, you have to find the derivative of negative 4.9t squared, and you get negative 9.8t, and then you just plug in 2, so you get negative 9.8 times 2, which is negative 19.6 feet per second. For number 12, you have to plug in pi into the limit, and then you get 3 times cosine pi, and cosine pi is negative 1, so it becomes negative 3. And negative sine pi is 0, so it's just 0 plus 2, which is 2, and then you get negative 1. For number 13, you have to find the limit as x goes to negative infinity, and since the powers are the same, you take the coefficients, which is 8 over 4, negative 8 over 4, so then it's just negative 2. For number 14, all you have to do is multiply 3 times negative 1 because it's f of x times g of x, so it's just it's positive 3 times negative 1, which equals negative 3.
We're doing number 17. I messed up earlier, and I'm not writing it over again, Campbell, I'm sorry. But anyways, when we're finding the Edma-Hafer, we have to divide every term in the function by the highest exponent. So we're dividing everything by x cubed here since the highest exponent is cubed. So we have everything over x cubed here, and all these other terms that are not x cubed and are not cubed in the numerator and the denominator are going to get canceled out, because if you substitute infinity in for them, they're going to equal 0. So they're not really important right now. So we're going to be left with 1 over 4. And for b, we're just doing the same thing. We're looking at the exponent, and we have x cubed over 4x cubed. And if you just get rid of that, it's 1/4. Okay guys, we're doing number 69 here, aka number 18. Anyways, we're looking at this graph right here. If the cameraman can zoom in on it, that'd be great. Okay, so anyways, we have a function here, and there's a removable discontinuity here at a, and there's a point above, and since there's a removable discontinuity, that means that this function is not continuous. So the answer is A. Okay, so now we're on 84, aka 19, and these are the instructions. I already did all my work here, so I'm just gonna have to do it on this other paper, since Campbell doesn't want me to do it over here. That's none of my business stuff. So anyways, we have f of x equals all of this stuff. So if we factor out the x squared minus 4, we have this. And what I did is I just used process of elimination. I looked at all these numbers, and whatever I'd substitute into A, it would end up canceling out with that. So I know that that'd be a removable discontinuity, so it would not be continuous. So I put in 1 for it. So let's say that we have A equal to 1 now. So we have x minus 1, x plus 2, x minus 2, all over x plus 1, x minus 1. And we can cancel out the x minus 1, so that doesn't work. With the 4, and here we'd have x plus 2, x minus 2, and that would cancel out these 4, so definitely not that one either. And E has 4 in it, and 4 didn't work, and it's not none because 2 works. So say that we put 2 in for A. Two doesn't have any factors that we can do that will cancel out with the numerator, so 2 does work. So 19 is C. Okay, number 20, we have the limit as x approaches 1 of x over natural log x. So what we do here is we multiply by e over e, and we have ex x over e ln x, and natural log and e are their inverses, or each other's inverses, so we cancel out. So we have x over x, and then we cancel out the x's, and we are left with e. Okay, so after I'm done with this last problem, I'm gonna go watch the Doyers game. And anyways, here are the points. X equals -3. This function is forever getting closer to -3, but it's never gonna get it. -1, it's it's a removable discontinuity, so it's not that one. 3. Where's 3 at?